Imagine the world you live in. You can move left or right, forward or backward, up or down. That's 3 dimensions. Add time, which flows whether we like it or not, and you've got 4. That's the structure of reality as we know it. But what if there could be a 5th dimension, hidden from our senses yet deeply woven into the fabric of the universe? And what if this mysterious extra dimension held the key to solving one of science's greatest puzzles? Dark matter. Some scientists believe this connection might be real. Dark matter is one of the strangest mysteries in modern physics. We know it exists because of how it affects galaxies and stars. Galaxies spin faster than they should if only visible matter were present, and stars at the edges remain bound together when gravity from ordinary matter should be too weak. Something unseen and powerful is at work. Dark matter makes up most of the matter in the universe, yet it doesn't interact with light or the particles we can see and measure. It's invisible and untouchable, as if it belongs to a different rulebook altogether. That's where the idea of a 5th dimension enters. One theory suggests that dark matter may be evidence of particles slipping in and out of this hidden dimension. In this view, particles called fermions, the building blocks of matter, could sometimes travel into the 5th dimension. When they do, they might leave behind relics or echoes that behave like dark matter. This could explain why dark matter is so abundant and why it's invisible to us. Our best framework, the Standard Model of Physics, explains how known particles and forces interact. It has been successful, but it doesn't contain a particle that behaves like dark matter. That's a strong hint we may be missing something. If fermions interact with the extra dimension, they could create what scientists call a bulk mass, forming a hidden dark sector beyond our perception, but real enough to shape galaxies and the universe itself. This raises a big question: how do we prove it? For decades, physicists have tried to detect dark matter directly, building sensitive detectors deep underground or smashing particles together at near light speeds. So far nothing. But new hope lies in gravitational wave detectors. Yet dark matter isn't the only place where other dimensions may hide. The universe is full of phenomena even stranger, and few are more mysterious than black holes. These giants swallow gas, dust, light, stars, and even other black holes. Once something crosses the event horizon, the point of no return, it is pulled inward forever. At the core lies what we call a singularity, a point of infinite density, where the laws of physics break down. Singularities are like rebels, shattering our theories about how the universe works. But in 2010, physicist Nikodem Poplawski suggested an alternative. Instead of ending in a singularity, the inside of a black hole might actually contain a passage to another universe. In this view, every black hole could act as a gateway. Our own universe, Poplawski proposed, might have been born inside a black hole in a parent universe. At the heart of this theory lies the concept of torsion, which is a property of space-time that becomes important under really extreme conditions. If torsion exists, it could actually stop singularities from forming. Instead of collapsing into a point, matter inside a black hole might create new space, expanding outward into a new universe. This idea connects to the Big Bounce. Instead of one Big Bang, the Big Bounce suggests a cycle of universes contracting, collapsing, and then rebounding to form new ones. Matter from a dying universe could pass through a wormhole inside a black hole and emerge in another, triggering expansion. Our universe might have begun this way. Unfortunately, the wormhole would be one way, so we could never travel back to the parent universe. Still, it's a breathtaking possibility. Evidence is hard to obtain, black holes are really difficult to study, and torsion might only show itself under extreme conditions. For now, it remains speculation. Yet it fits within physics in a way that makes it impossible to dismiss. As with the 5th dimension and dark matter, the door remains open. Now let's shift from the cosmos to the mind, which is honestly the most complex structure we know. Back in 2017, scientists from the Blue Brain Project in Switzerland studied the brain using a branch of mathematics called algebraic topology. And what they found was, well, honestly staggering. The brain appears to build and use geometric structures in up to 11 dimensions. Not physical dimensions like the ones we move through, but mathematical dimensions that reflect how neurons connect. Neurons form groups called cliques. The larger the clique, the higher the dimension it represents. So, like 3 neurons form a triangle, 4 form a pyramid, and larger groups form shapes of even greater dimensionality. The researchers discovered millions of these structures in small brain samples, most up to 7 dimensions, but some stretching all the way to 11. This means the brain, in its inner workings, builds shapes far beyond what we can imagine in physical space. Even more surprising, when the brain processes information, it seems to assemble these multidimensional shapes step by step, and then break them down again. It's as if the brain is constantly building and dismantling towers of geometry to think, learn, and respond. Nobody really knows why it happens so precisely, but it may reveal a new way of understanding thought. The human brain has about 86 billion neurons, each with countless connections. With such complexity, it's honestly no wonder we don't yet fully understand it. But this discovery suggests the brain is more than just a tangled web of wires. It may actually be a multi-dimensional architect, and if the brain can create patterns in 11 dimensions, maybe reality itself is richer and more layered than our senses reveal. From dark matter possibly tied to a hidden 5th dimension, to black holes that may spawn entire universes, to the brain revealing 11-dimensional structures, the universe keeps hinting at deeper truths. Each theory and discovery pushes us closer to the edges of the known, teasing us with what might lie beyond. Whether it's fermions slipping through portals, wormholes creating new worlds, or neurons sketching invisible geometries, one thing is certain: the universe is stranger and more astonishing than our 3-dimensional lives suggest. And perhaps in solving these mysteries, we'll discover that dimensions aren't just abstract theories. They're the hidden threads weaving together the very fabric of existence.